Looking forward to talking to all of you. This is an area with a lot of new technology. It's difficult to get really good information on this. So you may see some numbers here that differ from what you know, and neither one of them may be correct. Depends upon who you ask these days. So let me get started. I'm going to talk about ways to get IoT data to the cloud. So we're talking about generally small amounts of data and going larger distances most of the time. We'll be looking at a lot of new technologies, but comparing them to some existing ones, looking at their trade-offs and some examples of how they're used. In particular, we'll be looking at LoRa, Sigfox, LTE-M, NB-IoT. Zigbee obviously is old, and Bluetooth LE mesh. Now, just to get started, there's 3 different ways you can get data to the cloud from an IoT device. What people like the best is going directly. Your device talks directly to the internet. There's nothing in between. A cell phone does that. Very often, you don't have the power to do that. It takes a good amount of power to power a cellular modem. So you often have a gateway. A gateway, for example, a Wi-Fi device. Wi-Fi is a gateway. And then for some devices, they don't even have enough power to do that. For example, if you've got a wearable device, it may only have Bluetooth on it. It can transmit a few feet, and it'll transmit to a cell phone, and the cell phone is the gateway. So, so I've already talked about this slide, but I'll fill in a little more. The problem with cellular...
You're bypassing a whole lot of infrastructure there.
Yeah, I'm not going to go into a lot of details on this, just to brush the surface. So there's a lot of, there's high power required if you're going to be going directly to the cloud. If you only have a small amount of data, it's rather expensive. It is obviously used in automotive and consumer devices. For a network with a lot of devices, this may not be the best way to go. When you use a gateway, the downside of this is for a consumer device, it's not so great. That means you have to sell the consumer the gateway as well as the device, unless they're using Wi-Fi, for example, but I put Wi-Fi in the other category. It's used for things like home security. Enterprises use it a lot. One advantage for an enterprise is they don't have to connect to their own internal network, which they're usually trying to keep very private. And then the sensor connected through a cell phone obviously is really good for low power. So a small, portable, wearable device, this is a really good option. As long as it's near the cell phone. If it's sitting stationary in your house, it may not be near the cell phone. But it's used a lot in consumer devices, and not as much in enterprise. So for the new technologies, one of the biggest things that people are looking for is the distance. Right now, if you've got a low-power device, you're having trouble even getting it to go 100 feet. Getting to a gateway is a problem. So it would be nice if you didn't have to supply that gateway to every place you put it. So what we're going to talk about is new technologies that get a low-power device a long distance. Data rates are usually fairly low. Sometimes you're only sending a few samples a day. Now, and even if it's a few hundred samples or thousands of samples, it's very low data rates. And these devices are generally battery operated, so power is always going to be a problem. So the only thing we got as an advantage here is the rate. You're always trading off the distance, the data rate, and the power consumption. Because we have low data rate, something can work well here. And of course, cost is important. We'll talk about that. And I just want to repeat down here that the information about emerging technologies can be not so well known. So I'm sure there'll be some questions about some of the things they say. So here are some new technologies that will connect IoT devices. We'll talk about the ones in green. The ones in black, N-Wave and Z-Wave, I don't think they're going to become mainstream. I think it's already been decided that they're not going to be current products, or not going to get traction. At least that's my opinion. And I'd like to talk about some of the trade-offs. We've already talked about data rate, the distance, the battery size, and cost. Licensed versus unlicensed is important. Whether the carrier deploys or the customer deploys, how mature the technology is. And there's a lot of other things over here in black that I don't think I'll get time to talk about, at least not very much. So here's a comparison of these standards with Zigbee over on the side, just as something that's, it's been used in this field for a long time, so it's good to compare. So you see that LTE-M, well, in fact, all of these go long distance, except for, of course, Bluetooth LE mesh. Bluetooth LE mesh has the same characteristics as Bluetooth as far as power and distance, except that if you put it in a mesh, you can go long distance if you have a large mesh. Now, all these technologies claim they go 50 kilometers. This is in ideal conditions. In actual use, you probably won't get that. In fact, in cities, they claim more like 2 to 5 or 10 kilometers. So it's a whole lot better than Bluetooth, but you got to take with a grain of salt the numbers that the manufacturers give you. There's some interesting things about the data rates. Bluetooth LEM, Bluetooth LTE, LTE-M claims 1 megabit per second. If you took that rate, you'd be using up all the bandwidth. There wouldn't be any other devices operating at the same time. So it's not really the rate you're going to use. Same thing with NB-IoT. Not really going to be running at 250 kilohertz. Sigfox actually has a maximum of 300 bits per second. And that sounds really low compared to most things we're familiar with. But for these IoT devices, that gets you can send a lot of data in a day. That's all. A lot of data. I think you can approach a gigabyte in a day. LoRa has a more modest. Bluetooth LE mesh, modest. And Zigbee. And then I'll talk to you about what public and private is. You'll notice the LTE-M and NB-IoT are very similar. Sigfox and LoRa are very similar with some notable differences. Yeah?
Is there another name for NB-IoT? Because I'm not familiar with it.
Yes. Let's see. I brought my expert, my VP of Engineering. John, what's the other term for that?
It's a cellular standard part of LTE.
Oh.
And the LTE narrowband.
Oh, it's an LTE variant.
Yeah, okay. Yeah, I'm going to go into some details about each one, but I want to do a comparison first.
So I'm very surprised you don't have Wi-Fi on the list.
I'm going to compare Wi-Fi a little later on. Yeah, it's an interesting one to compare to.
I have a question.
Yeah.
So for video IoT devices, would you consider 250 kilobits per second too much, too low, or?
You're going to have a hard time sending live video at 250
Say it's
kilobits.
compressed.
Even compressed. That's not full frame, 30 frames a second. You'd have this is definitely not intended for video. So it's even not really intended for audio. So you could do audio on some of this. So let me give you a few examples of where you would use these. Let's take a small wearable device. It's going to send data to the cloud every minute. It's fairly often. And you want the battery to last a long time. You don't want to recharge it every day, so it's going to last several weeks. There's a lot of cases where people have devices like this. If you could use all of these technologies, Bluetooth LE mesh could work, but it's not going to go direct to the cloud, so I'm already violating that. Zigbee, again, it needs a gateway. LoRa can go directly to the cloud with a service provider, but LoRa also has the opportunity of you provide the gateway, because right now service isn't available most places. So you might have to provide the gateway. Sigfox only goes directly to the cloud. You don't have a gateway. So if there's no service, you can't use it. Now,
I don't know what that means. I don't know what the interface to the cloud is.
So
As far as I know, the cloud's a cloud. It's a virtual entity somewhere in the internet.
I'm talking about connecting to the internet. So
Through what?
Sigfox, you connect through a service provider, just like you do with a cell phone. So LTE-M and NB-IoT,
So
it's a cellular.
It's a cell phone infrastructure.
Well, yeah. For LTE-M and NB-IoT, it is a cell phone infrastructure. For Sigfox, it's a different infrastructure. It's not cellular.
But similar.
But similar. It's a service provider like that, yes. So all these technologies work for this one. If we get to this is a small device where we want to send data a mile every hour, and the battery's going to last for a year. Right now, before these new technologies, you couldn't do that. So this is something new that you can do with LoRa and Sigfox, and also with LTE-M and NB-IoT. For this device, we'll get into the cost. The charges may be a problem for the cellular-based ones. And again, LoRa might need a gateway. And now here's another one where you want to transmit the data a mile every minute, and you want the battery to last for a year. So this is a faster data rate. This is something you can actually do with LoRa. Getting the battery to last for a year, the NB-IoT, the cellular-based ones probably aren't going to be able to do that. They do claim you can do that, but it's a 5,000 milliwatt, 5 watt-hour battery. That's not a portable device. So Bluetooth LE mesh could do this, but again, you'd need a gateway or a really, really large mesh if you covered a mile. So the private and public. A private network is one where you control both ends. You install a gateway to the internet, you have the devices, it's all your network. It may be going over using a frequency that's available to others. It might be one where it's shared and you could get interference, but it's a private network. You can install it anywhere you want. You could be inside a building. It could be in places where there's no service from others. Typically, it's unlicensed spectrum, so interference can be an issue there. You have to pay for both ends, so that's why for consumers it can be inconvenient. But there's no monthly fee. Once you've installed it, you're all set. With the public, this is cellular, or things like it. So the service provider provides one end. The advantage is it's easy to roam, but if they haven't provided a service, then you can't use it there. So cellular now is pretty widely adapted all over, but there's still places where it doesn't work. I was in Eastern Oregon recently, and outside the cities, there's no cellular connection. With these new technologies, it's much, much more limited. These use a licensed spectrum, so there should be an advantage that not so much interference, but you've all had the experience of your phone call dropping because there's too many people using it. So to me, that's almost the equivalent of having interference with an unlicensed spectrum. You have a monthly charge, which is pretty significant on a public network. Now, I want to differentiate between LP WAN, this is low power WAN, and cellular IoT. The LP WAN is, that's the things like LoRa and Sigfox. And cellular is the LTE-M and NB-IoT. They're based on the cellular network. So that answers the question you had earlier. So when I talk about LP WAN or cellular IoT, that's the difference. So now let's talk about some of the details about each one of these technologies. LoRa actually can be a public or a private network. The intention is that they're going to be building it out, and you'll have LoRa available just like you have cellular coverage available wherever you go. It's certainly not that way yet. The next slide will tell you a bit more. And it runs, let's see. Well, right now, Senet is the only company in the U.S. that's installing base stations. There's a disadvantage to not having competition. That generally affects the price. We'll see what happens in the future. LoRa is very low power, or it can be very low power. Now, if you want to transmit a lot of data a long distance, the power goes up. And I'll have some numbers for you shortly. It's really intended for sending infrequent messages. It's not intended for things like audio. It has an advantage that you can send data both directions. So if you have a device that's periodically sending data, you may want to tell it to send the data at a different rate, or to send different data, or some kind of information for that device. You can send that data to the device as well as having the device send you data. That's bidirectional. It's in the unlicensed band, different bands worldwide. The cost for a gateway itself is fairly expensive, but for the monthly service, right now it's under $1 a month, and potentially could be well under $1 a month.
Is that per device, or is that just?
Yeah. How many stations can you put on a gateway?
I'm not sure. John, do you know the answer to that? How many stations you could have on a gateway?
Lots. It's data rate limited.
Okay, yeah, so if one of them is running it at the full bandwidth, then you could only have one. If they're running at really, really low rates, you can have a very large number. I don't know what the maximum would be. So let's talk about, yes.
Is latency a consideration?
Yes.
Because when we talk about data rate and latency are quite the same thing.
Yeah. Latency, I've not got a lot of, I've got a little bit about latency, but LoRa is pretty good about latency. But if the devices are normally going to sleep between transmissions. So the technology can do a fairly short latency, but if you go to sleep for an hour before you transmit again, and you try to tell that device something, it's not listening. So you essentially have a 1 hour latency. So let's take a look at how well adapted LoRa is. It right now is available in the US and Australia, New Zealand, Taiwan, and the Netherlands. That's pretty good, but there's some countries where it doesn't exist. It's being used largely by enterprises where they handle both ends. They like it because it doesn't get into their networks. And it's very cost effective for a large number of devices. It's used in things like parking. There's some devices here that are tracking parking and desk utilization, just detecting if someone's at the desk. Just some examples.
That's 1 bit per device.
Well, one device is...
No, the desk utilization is occupied or not occupied. That's 1 bit.
Yeah. It doesn't have to send much data, exactly. Yeah. Now, one transmission is going to be more than 1 bit.
Sure, it has to identify itself.
Yeah.
Do you provide anti-collision? So if messages are right at the same time, you tell them what to do.
John, do you know? I believe it's got that covered. What about collisions? Is there collision avoidance when 2 devices transmit?
It's actually a spread system, so it actually works really well.
Okay, so it spread spectrum and handles collisions very well. So LoRa's gotten pretty good availability, and it looks very attractive as far as becoming a standard. Sigfox is really a competitor to LoRa. It's only available as a public network. Now, it's not cellular. This is a public network that's being set up outside of cellular, as we mentioned. It's also low power, very low power. it handles only low data rates. I showed you the 300 bits per second. And again, it's good for infrequent messages, small messages.
So what's a base station service radius?
Well, it's theoretically can go many miles, 50 kilometers. But that all depends, not in the city. I'll talk some more about distance. And distance trade-off with speed. You cannot go bidirectional with Sigfox. So if you've got a device and you want to tell it how to send the data, Sigfox is not a good solution for you. The base stations are more expensive than LoRa, but since the service provider is installing them, that's not really a big deal. It's using the same unlicensed band as LoRa. The modules, now when I say $3 for a module, this is the module that goes into a device. So if you're selling devices to a consumer, it adds $3 to the device, or more than $3. There's a range in prices. If you get down to the $3 range, that's pretty inexpensive. And the cost can be $1.50 per year. That's pretty inexpensive. Now, and up, there's a wide variety here. Pricing is all over the map right now on all of these.
$3 include the battery?
No, that $3 is just the RF module. Doesn't include the sensor, the battery, the processor, the enclosure, any of that stuff.
Can you clarify what you mean by unidirectional only, so you
Yeah.
don't get that knowledge even?
Unidirectional means it only sends data. It doesn't
You
receive.
don't get that knowledge. Meaning that
That's
you
right.
don't get confirmation if the packet I send is delivered or not.
Yeah.
Sean, is there any confirmation so you send the data and okay, so he says no acknowledge. If the data is not received, you don't know, or the device doesn't know that it wasn't received.
When you say not cellular, do you mean that their base stations are not co-located with cell sites, or do you mean something different?
They're not using the cellular frequencies. They're using unlicensed band.
Or the cellular
modules. Sigfox base station is not available, switch it over to 7.
Say that again?
Can you have a hybrid module?
Oh.
Switch over between two but it's not available.
Okay, so the question is, can you have a module that switches over from Sigfox to cellular when Sigfox is not available? I don't think there's any module available today that would do that, but you could put in 2 modules. So, but that's, putting in 2 modules and paying for the service for 2 of them would not be desirable. So that's not a very practical solution. So Sigfox doesn't have very good traction in the US, but it's based in France. It's got good European coverage. There's 21 countries, France in particular, well covered. There's a plan to put Sigfox in 100 cities, but no date given for when that'll happen. So right now, if you're putting something in the US, it's not a good idea to build using Sigfox. It's used for things like utility meters, like up here, and city light poles. Light poles are becoming an important place to collect data. Now, Bluetooth LE mesh, this is quite different. I put it in here for comparison, but if you don't have a very large mesh, it's not going to transmit very far, but the power is even lower than these others, so it's worth looking at. It's also new. Everybody's familiar with the distance Bluetooth goes, and the power that it consumes is very low. When you put it in a mesh, it's very attractive for a lot of applications. And this one is on a private network, typically connected to phones or tablets. It's just been announced. It's been in the works for a while, so people have known of it, but it's just announced. They expect to actually have the first devices shipping next year. And a few smartphones and a few tablets have the capability. So it's pretty new, but it's good to know what's coming. And this is really designed for home automation. If you put a mesh in a home, then all the devices can communicate.
So this would be a software add-on to a phone or tablet that had Bluetooth.
I believe it's more than software. It's primarily software. John, do you know if there's any hardware change in Bluetooth LE to make it mesh? I think that it requires some hardware because they're not just able to update your phone and have it do mesh. Yeah, I think so. And so there's a little hardware involved. Your existing phone isn't going to get Bluetooth LE mesh. And now Zigbee, not as popular as Bluetooth, but it's been around a long time. Also very low power, short distance, but longer than Bluetooth or Bluetooth LE. And Zigbee can do a mesh network. It's been the way to do mesh networks for a long time. It's a private network, and the downside of Zigbee is that it's not in phones and it's not in PCs. So in a lot of cases where you want to sell a device and have something that it already can connect to, Wi-Fi, cellular, and Bluetooth, you can connect to other devices easily, but not Zigbee. So it's used in applications where that's not important. So it was introduced 14 years ago, and it's very well established in certain areas. The market's growing slowly, though. But smart metering, it's very popular. Industrial monitoring and lighting. Many lights are provided with Zigbee in them. So this isn't going to go away anytime soon, but it doesn't look like it's going to gain a lot more traction. Now we get into the cellular-based applications, or cellular-based communications. So LTE-M is narrowband cellular. It uses higher power when it's transmitting. It's not as low as the LoRa and Sigfox. But if you're sending a small amount of data, you go to sleep most of the time. And that means that the average power is quite low. And again, it's good for infrequent messages, but you can send messages pretty fast. I'll get to that in the table. LTE-M is very good for low latency. It can respond very quickly to messages to it. Now, the modules for the LTE-M are more than $10 a piece. So we're talking about more expensive modules. That's a downside. The monthly charges, you can see they're kind of all over the map, from 30 cents to $2, depending upon the service provider. I don't know where it'll settle out. I have a feeling that cellular is going to end up costing more per month than LoRa and Sigfox, but we'll see. Oops, wrong direction. So LTE-M has good US coverage already with Verizon and AT&T. European coverage is growing, but they expect to have good coverage in 2 years, so it's going to be a while yet. It's not yet available in phones or tablets, but that's not so important. If you're going to have a device, it's going to communicate directly to the cloud. And it's being used now in asset tracking and digital signs. So these are things that need more frequent communication, or they're sending larger packets of data than what you'd use for LoRa or Sigfox. And now we'll look at NB-IoT. It's again narrowband cellular. In many cases, it has very similar characteristics to LTE-M. One disadvantage is it's not so good for moving devices. When it disconnects, it takes many seconds to reconnect. And the costs are in the same range. The modules are more than $10. I haven't seen anybody offer it for less than $10 a month. But since prices are changing rapidly, who knows where it's going to end up. NB-IoT is primarily in Europe China is installing it aggressively, but not much in the U.S. T-Mobile says they'll have it in 2018, so coming soon. And Sprint, they haven't decided, but they said they might do it.
Especially if they merge with T-Mobile.
Yeah. Yeah. Mergers would change everything. The NB-IoT was a leading contender, and then they had technical issues, so it fell behind LTE-M in development. And it's only recently did they make final updates to the specs. It's very good for gas metering, agricultural sensors, and municipal lighting. So now let's take a look at a chart to compare them. As I pointed out, oh, there's a question back here?
Yeah, I have a question. So, if you're a whole manufacturer, you are stuck with two different radios, one for narrowband and one for FDM.
Well,
if you are designing a device, not you're stuck with trying to pick one or the other.
typically a device doesn't need to have both cellular and narrowband, so you're going to be one or the other.
You've got carriers who are taking two different routes. You've got T-Mobile on one side and AT&T on the other. So the phone depending on
Oh, as far as the device, yeah, one of them is doing NB-IoT, one maybe doing LTE. I'm sorry?
if you're looking for a gateway for your device to talk to.
Well, the cellular suppliers are providing gateways, so you don't have to provide that. But their gateways have to be able to accept what you're sending. And I don't believe anybody's offering both LTE-M and NB-IoT. So this is kind of like problems we've had before with new technology. You get one technology with one supplier and another technology with the other supplier, and one of them may end up being the winner, but we don't know who it is now. I don't know if I answered your question.
Oh, I mean, if I'm designing a device today, we really don't know whether I should be picking one or the other, because obviously you can't put two radios in the same device to make it power.
Yeah, so the question is, how do you choose what device to use today? And I don't know. It's too early. The winner is not clear. Yes.
Is NB-IoT, what cellular network is it based on? Is it also LTE or is it a different cellular network? 3G?
It's based on LTE.
It's also LTE.
Yeah. So let's compare the data rates, the distance, and the power. First, I'll do it for the LPWAN, the lower power devices, and compare them to some standards that we know. So we've got LoRa and Sigfox. You'll see that when we get to a long distance, they're the only contenders. At 50 meters, Zigbee works. Zigbee claims 100 meters, but I wouldn't want to rely on it. And then at the larger speeds, the higher speeds, I mean, Zigbee and LoRa are left. Though LoRa isn't really intended to send data at this rate. So they claim they can do this. You can do this if you have only one device connected. But normally you're going to have a lot of devices.
So are all of these assuming non-directional antennas?
Yes, as far as the transmitters, these are IoT devices. You wouldn't normally have a directional antenna in an IoT device.
If you had a fixed IoT device, you could aim it.
You could. These numbers are so uncertain that going to a directional antenna may not change them very much. You know, it depends,
Better answer, okay.
depends on so many things. All I have to do is put it up on a pole, and it could be 10 times better. Because if it's a wearable device, putting it on a pole isn't very attractive.
Put it on a check instead.
I have a question about that.
Yeah.
The power, these are power numbers, right? The milliwatts.
Yes, these are the
This is
milliwatts.
during transmission. This is
During
power
transmission,
numbers.
yes. So these numbers here are taking into account that if you send 100 bytes a day, it's off almost all the time. So it's not going to take 20 milliwatts average during the whole day. Yeah. That's peak. And now, while it's transmitting, it may even have some periods where it shuts down. But this is, so if you were continuously transmitting, this is what the power would be.
And what's the overhead for establishing the connection? Is it different between the two?
I don't have data. The question is about the overhead for establishing the connection. Because they're intended for low data rates, the overhead is small, but I don't have a comparison.
Yes, in the first column, especially with these kind of data rates, is there any thought given in the applications for cryptography or protecting the payload, or is it all just about payload and the low data rates up here are there any applications that are encrypting the data?
Oh, encrypting. So encryption is largely the responsibility of the company that's creating the device. The wireless technology has various levels of protection. If it's digital, you can't just read it directly real easily, but it's not really secure. So if you want to have security in the data, then you're going to need to encrypt it before you send it.
Well, I think maybe it will help clarify a lot of things. I mean, basically, this right here, you're saying is just RFPA peak power. That's it, correct?
Yes.
Okay, so that means, I mean, in terms of an application, what you do, the device and everything, that's all completely normal outside of the data you're showing. There's nothing to do with this. Is there RFPAs that could go into anything, an application,
yes.
High power, low power, a lot of overhead, encryption, no encryption? I think that helps to really clarify. You're focused on just peak RFPA power
just transmitting
in a widget.
Yeah, so the device is going to have a sensor that's consuming power. This device, the transmission is going to be shut off most of the time. All of that is a separate consideration.
Right, because I mean, before, the only thing you kind of indirectly quantified, right, you were showing battery life, right, but that's device power. So I don't know if you were quantifying that specifically in regard to this RFPA peak power, or if you had some example widget or device in mind that took advantage of one of these, and that's what you're basing your battery life calculation on.
When I'm talking about battery life, I'm focused on the RF part, but you can certainly have a device where the RF is minor compared to other things going on.
Right, so your battery life, as you expressed it, is only if 100% of the battery was devoted to RFPA.
Yes. Yeah.
Okay. All right.
Radio battery.
Right.
Yeah. So, yeah, I'm not considering all the other things that are going on in the device, just the RF.
Right.
Yes.
It seems that the IoT is very similar with LTE-M. What is the main difference between them?
Well, the biggest difference right now is where they're deployed. You don't have NB-IoT in the US yet. So that's a major difference. A minor difference is that NB-IoT is, I got to look back myself. No, it's not so good for moving devices. It's got a long latency. When it disconnects, it takes something like 5 seconds to reconnect. So for this sort of thing, that's a long latency. For some devices, that's not long. Depends upon the application. So there's not
Can it connect while it's moving?
It can connect, but if you move out of range, it disconnects. And takes a while to reconnect.
As long as it's within the field of the gateway of its gateway, it can connect while moving.
Yeah. For those who didn't hear it, as long as the two devices are close enough together, both in the same field, you can connect with two moving devices, or one device that's moving and a stationary device. It's just that it's not designed for this because of the difficulty of reconnecting, the length of time it takes. Okay, so you can see that Bluetooth LE mesh and Zigbee are really good for the low speed and medium speeds, but not very good. And Zigbee moderate distance. Yes. The data in this chart, this data is from a variety of sources. It's mostly from data sheets, but there's some subjectivity to it. So you can easily find another source that gives you different data. And in fact, when you're comparing data rates, this can be a little confusing because we're talking about things that are transmitting infrequently. So the powers up here at these higher rates may not be very important for these devices. This column is the important column. Yeah, so these power numbers here are, take a look at it, the low data rate. This is where this technology is intended. And now if we look at the cellular IoT compared to Wi-Fi, Wi-Fi is actually unique at short distances. If you're 10 meters in cell tower, it may not work. But that's an unusual situation. So in green are the ones we're talking about, LTE and NB-IoT. They can go a long distance, but they're certainly not good for the high speed, where Wi-Fi can handle really high speed. And plain old LTE can get really high speed, but it may not get that speed if you're far from the cell tower. So, and notice these powers here, you don't even have one for NB-IoT. It's probably in this range. So we're in hundreds of milliwatts, where the previous chart, we're in closer to 1 milliwatt. So there's a very significant difference in the power dissipation. But if you're shut off most of the time, it may not even be significant. It depends upon the application. And I've given you some numbers, and here's some costs for the device. But this is just the RF module that goes in the device. Bluetooth LE mesh is definitely going to be the cheapest. And the two cellular-based ones are the most expensive. And I'd like it to stay that way. I don't have infrastructure numbers for all of this. What's probably the most important is the connectivity cost. If you spend $10 for the device and you spend $1 a month, in a year you've already spent more for the connectivity. However, if you're selling the device to a consumer, he may care more about what he pays today than what he pays in a month. So it all depends.
So if you've got a low duty cycle, can you put multiple devices on a single infrastructure service?
I'm not sure how this is per some unit of data, like some megabyte or so, several megabytes. John, do you know how they do the charging for multiple devices?
I think there's different cost structures. Some are per device, and the other is aggregated on the different.
Okay. So there's a lot of different cost structures. Different service providers are going to have different costs. So it's really hard right now to talk about cost. They vary 5 to 1, going from one place to another.
Is there some floor amount of transmission and power that's required just to keep connectivity to the network, stay logged in?
The question is, do you need to have a certain amount of power and connectivity to stay logged in? These can be completely shut off, and they reconnect quickly. So it's not like a cell phone where if you don't continuously ping, you lose the connection.
Well, Wi-Fi is not like that either.
Yeah.
I mean, you can't completely shut off Wi-Fi.
Right.
You need to maintain your association.
Can't do that with Wi-Fi, yeah. Is there a question over here?
Well, I was just saying that your typical, the cellular people have to charge for every billing activity. And the rule of thumb is typically about $4 or $5 a month per customer. If you have service where you've got 1,000 endpoints, that's not like 1,000 customers. They're really only one bill, so they have a whole different pricing structure. As Paul said, you know, they aggregate. Because there's the cost of the operations of the building, then there's the cost of actually using services on the network. And if you have devices that are talking very frequently, it doesn't bother the cellular network very much. So it can, in theory, give you a pretty good price.
Yeah.
And with software, you can make them all look like the same device.
Yeah, but you may not want to do that.
So if you didn't hear, the comment is that you can, the cellular providers can aggregate when there's a large number of devices and very low data.
In general, what you've shown here is a solutions list once you understand what your problem is. Because as you approach a problem like this, you have mobile endpoints, and when you talk about it doesn't connect very much. If you're talking to a vending machine, that's not important. It doesn't move very much. Right? In fact, if you're talking to a vending machine, power is not really important. It's typically plugged in the wall. But the other key factor is, does the operator need to update the software on the device? When you said you can't download information to the device, that can be a serious problem.
Okay, so a good comment about updating the device software. Not being able to transmit to the device means you can't update it.
Even if you can, even if Laura says you can, or Sigfox, one of those two says you can, you actually can.
If you're going to transmit several megabytes of data, these are not good technologies for that. You could do it, but it takes a long time.
Well, that's fine, but the thing is, if you have vending machines, or for that matter, agricultural pumps out in the field, you don't want to have to physically go to each one of those pumps to upgrade, if in fact you make a software update.
The upgradability, and the ability to download new software, we'll see how that works out, because if everybody started updating devices all over the world, that could have a major impact on the amount of data going over these networks. That could be a problem.
The networks don't see each other. You know, you only have to worry about the radio coverage.
Yeah. Granted, it's only in a small area, but it could be a lot of data. Okay, I'm going to, well, I'll summarize and that'll be the end. So it's not clear to me which standards are going to win or lose. But there's also room for more than one standard. I don't think out of all these that I've talked about, only one will emerge. I think several will. It's going to take probably a year or two before we find out who. So in the meantime, if you're designing devices, I guess the only thing I could recommend is plan on having the gateway as well as the endpoint, and then you don't have to worry about how well deployed they are and who wins. Okay, thank you. Oh, by the way, we'll be putting out an article on this, so if you'd like to get that, just give me your card.